Welcome you all back to the class this week. Here are the objectives of our lesson for this week. Objective number 1, at the end of today's lesson, all the students in this class should be able to state what happened at anode and at cathode in the electrolysis of concentrated sodium chloride. Objective number 2 is that at the end of today's lesson, every one of us here in this class should be able to state what happened at anode and at cathode in the electrolysis of dilute sodium chloride. Objective number 3 is that at the end of today's lesson, all of us should be able to state what happened at anode and at cathode in the electrolysis of molten sodium chloride. Number 4 is that at the end of today's lesson, everyone in this class should be able to write the equation for the reaction at anode and at cathode in the electrolysis of sodium chloride, be it concentrated, dilute, or molten. And lastly, at the end of today's lesson, all of us here should be able to write the overall equation for the reaction in the electrolysis of sodium chloride. Once again, welcome back. Let's begin with the electrolysis of concentrated sodium chloride using platinum or carbon electrodes. Carbon and graphite electrode, they mean the same thing. So if I say carbon or if I say graphite, the two of them are saying the same thing. So concentrated sodium chloride is also known as brine, and in this particular solution we have more sodium chloride than water, and that's why it is referred to as concentrated sodium chloride. So in the solution, the sodium chloride is more in terms of concentration than water. So sodium chloride will produce sodium ion and chloride ion, while water will produce hydrogen ion and hydroxide ion after dissociation. And sodium ion and hydrogen ion, being the two cations present in this solution, will migrate to the cathode, but hydrogen ion will be discharged because it is lower in the electrochemical series than sodium ion. It is less electropositive, while sodium is more electropositive. So the one that is less electropositive will be discharged, and that is the reason why hydrogen ion will be discharged. But we have hydroxide ion and chloride ion as the anion present, and they will migrate to the anode. So chloride ion will be discharged because it is formed when sodium chloride dissociates, and sodium chloride is more concentrated, so the ions produced by sodium chloride will be more concentrated than the ion produced by water. So chloride ion is more concentrated than hydroxide ion, and because of that, chloride ion will be discharged because of its concentration in the electrolytes. So this is what happened. Hydrogen ion is discharged at the cathode and it liberates hydrogen gas. These are the ions produced by water. This is hydrogen ion, this is hydroxide ion. These are the ions produced by sodium chloride, sodium ion and chloride ion. So the chloride ion migrates to the anode, and hydroxide ion also migrates to the anode, but chloride ion is discharged because it's more concentrated and it will liberate chlorine gas. This is the reaction at anode and at cathode. At anode, we have chloride and hydroxide ion. So the two of them migrate to the anode, but chloride ion is discharged because it's more concentrated than hydroxide ion in the electrolyte. And of course, what will happen is a univalent element but diatomic. So what will happen? Chloride ion will lose one electron to form a neutral chlorine atom, but chlorine, because it's diatomic, cannot be represented as just ordinary Cl in any chemical equation. So two neutral chlorine atoms will pair up together to form chlorine gas. So at anode, in the electrolysis of concentrated sodium chloride, Cl minus, that's chloride ion, is discharged at anode, but chlorine gas is liberated. This reaction is oxidation because electron is lost. So at cathode, we have sodium ion, we have hydrogen ion. The two of them migrate to the cathode, but hydrogen ion is discharged because of its position in the electrochemical series. Hydrogen ion is less electropositive, while sodium ion is more electropositive. So therefore, hydrogen ion is monovalent but diatomic. So it will gain one electron and produce a neutral hydrogen atom. That is reduction reaction because the electron is gained. So but hydrogen cannot be represented as ordinary H in any chemical equation because it's diatomic. So what do? Two neutral hydrogen atoms will pair up together to form hydrogen gas. So at cathode, in the electrolysis of concentrated sodium chloride, hydrogen ion is discharged, but hydrogen gas is liberated. Here is the overall equation for the reaction at the anode and at cathode in the electrolysis of concentrated sodium chloride. The reaction at anode is the one we refer to as anodic half reaction. The reaction at cathode is the one we refer to as cathodic half reaction. Two halves combined together is equals to 1. So we have chloride ion discharged at anode. It loses one electron to liberate chlorine gas, but you will discover the equation is not balanced. What do I need to do? Two chlorine atoms are here, but one is here. What do? Put 2 here. But if one chloride ion loses one electron, by the time I put 2 here, that means 2 will lose 2 electrons. Then the equation is balanced here. So at cathode, hydrogen ion gain 1 electron to liberate hydrogen gas, but the equation is not balanced. There are 2 hydrogen atoms here at the product side, but there is just 1 hydrogen. What I need to do is to put 2 here. So 1 hydrogen ion gained 1 electron, 2 will gain 2 electrons. The number of electron gain is 2. The number of electron loss is 2. The equation is balanced, and then the number of electron gain and the number of electron loss cancel each other. So what I need to do is combine the reactants at the cathode and at anode together, and that's what I have here, and then the product at cathode and at anode together, and that is what I also have here. So this is the overall reaction for what happened in the electrolysis of concentrated sodium chloride. Let's move on to electrolysis of dilute sodium chloride using platinum or carbon electrodes. But here you hear the word dilute. It's different from concentrated. So in this particular case, we have more of water than sodium chloride, and that is why it is referred to as dilute sodium chloride. So sodium chloride, we produce sodium ion and chloride ion. Water will produce hydrogen ion and hydroxide ion. Sodium ion and hydrogen ion will migrate to the cathode because they are cations. Hydroxide ion and chloride ion will migrate to the anode because they are anions. But hydrogen ion and hydroxide ion will be discharged or are discharged at the cathode and at anode respectively. And for what reason? The reason is because they are the least in their respective electrochemical series. So meaning that at the for cation, hydrogen is less electropositive than sodium ion, while for anion, chloride ion is hydroxide ion is less electronegative than chloride ion. So if hydrogen ion is discharged at the cathode, hydrogen gas will be liberated, and hydroxide ion is discharged rather at anode, oxygen gas will be liberated. Let's look at the reaction at anode and at cathode in the electrolysis of dilute sodium chloride. At anode, we have chloride ion and hydroxide ion as the anions rather present in this electrolysis. But hydroxide ion is discharged because it is less electronegative in the electrochemical series than chloride ion. So if hydroxide ion is discharged, it will lose one electron to produce or to form a neutral OH group. Two different OH group will combine together, we pair up together to form a molecule of water and O, which is representing oxygen, by the way. But oxygen is diatomic in nature and cannot be written as ordinary O in any chemical equation. So two oxygen atoms, two neutral oxygen atoms will pair up together to form oxygen gas. So in the electrolysis of dilute sodium chloride using platinum or carbon electrode, hydroxide ion is discharged at anode, but oxygen gas is liberated. At cathode, we have sodium ion and hydrogen ion as the cation present, and the two of them will migrate to the cathode, but hydrogen ion is discharged because it is less electropositive than sodium ion in the electrochemical series. So hydrogen ion will gain one electron to form a neutral hydrogen atom, and hydrogen is not represented as, can never be represented, written as ordinary H in any chemical reaction. So two neutral hydrogen atoms will pair up together to form hydrogen gas. So at cathode, hydrogen ion is discharged, but hydrogen gas is liberated. This is the overall equation for the reaction at anode and at cathode in the electrolysis of dilute sodium chloride. Hydroxide ion is discharged at anode. It loses one electron to produce a molecule of water and oxygen gas. But this equation is not balanced. One oxygen atom at reactant, three oxygen atoms at the product. We have done this before, class. So what do we do? Put 4 here, and what do you have? 4 OH minus, we lose 4 electrons. But the equation is not still balanced because we have 3 oxygen atoms, but we have 4 here. We have 2 hydrogen atoms, but we have 4 here. So what do I need to do? Put 2 in front of H2O, and then you have 4 oxygen, 2 here, 2 here, 4 oxygen, 4 hydrogen, 2 times 2, 4 hydrogen. So this is the overall reaction of at the anode. At cathode, we have hydrogen ion gain 1 electron to liberate hydrogen gas, and the equation is not balanced as well. What do I need to do? If I put 2 in front of hydrogen ion, then I have 2 hydrogen, 2 hydrogen, and 2 moles of electron is gained. But the number of electron gain and the number of electron loss are not yet the same. So what do I need to do? What I have to do is to multiply the whole of this equation by 2. So if I multiply this equation by 2, I have 2 times 2H plus to be 4H plus, 2 times 2E minus to be 4E minus, and 2 times H plus to be 2H plus. Then the number of electron gain and the number of electron loss are now the same, and they can then cancel each other. So bring the reactant at cathode and at anode together, and as well as the product and at the anode and at cathode, and that will give us this as the overall equation for the reaction at anode and at cathode in the electrolysis of dilute sodium chloride. Let's look at the third aspect of it, which is the electrolysis of molten sodium chloride using platinum or carbon electrodes. So in this case, molten means without addition of water, meaning we have only one compound, which is sodium chloride itself. So sodium chloride will then dissociate to form sodium ion and chloride ion. Sodium ion, being the cation, will migrate to the cathode and will be discharged because it's the only cation. And chloride ion, being an anion, will migrate to the anode and be discharged because it's the only anion. So what would then happen? This is sodium ion migrating to the cathode. This is chloride ion migrating to the anode. Chloride ion migrates to the anode and liberates chlorine gas. This is a molten sodium chloride. It does not contain water, and that is what the meaning of molten means in this case. Reaction at anode and cathode. For the anode, we have chloride ion being the only anion and is discharged, and it will lose one electron to form a neutral chlorine atom, and two neutral chlorine atom will pair up together to form chlorine gas. So at anode, in the electrolysis of molten sodium chloride, chloride ion is discharged, chlorine gas is liberated. At the cathode, sodium ion is the only cation. It migrates to the cathode and is discharged. It will gain one electron to form a neutral sodium, a metallic sodium, and that is a reduction reaction because an electron is gained. The overall equation for the reaction at anode and at cathode in the electrolysis of molten sodium chloride. Chloride ion is discharged. It loses one electron to liberate chlorine gas, but the equation is not balanced. We have two chlorine atoms on the product side, one chlorine at the reactant side. What I need to do is to put 2 in front of Cl minus, then I have what at the back of Cl minus. So I have 2 Cl minus losing 2 electrons to liberate chlorine gas. So 2 chlorine atoms, the equation is balanced. At the cathode, sodium ion gained 1 electron to form a metallic sodium. 1, 1. The equation is balanced, but we cannot leave it this way because the number of electron gain does not correspond with the number of electron loss. So what we need to do is to multiply the whole of this equation by 2. So it will be 2Na plus 2 times Na plus 2Na plus 2 times E minus 2E minus 2 times Na 2Na. So 2 electrons gained, 2 electrons lost. The 2 cancels each other, and then what we need to do is to bring the reactants at the cathode and at anode together, and that will give you this. Bring the products at anode and at cathode together, and that will give you this. Then this is the equation of the reaction at anode and at cathode in the electrolysis of molten sodium chloride. What have we learned in our lesson today? Today, we've been able to look at what happened at anode and at cathode in the electrolysis of concentrated sodium chloride. We've been able to look at what happened at anode and at cathode in the electrolysis of dilute sodium chloride. And we've been able to look at what happened at cathode and at anode in the electrolysis of molten sodium chloride. We've been able to also write the equation for the reaction at anode and at cathode in the electrolysis of sodium chloride, and at the same time we've been able to look at the overall equation for the reaction in the electrolysis of sodium chloride, be it concentrated, dilute, or molten. Here is my email address for your comments and for your questions. My name still remains Ibukunolu Ademola.